Today I'm going to start few more things in the pointers only, like null pointer, void pointer, constant to a pointer, constant pointer, and then dynamic arrays. Okay, or to create dynamic arrays using pointers. So before I proceed, I'd like to give you a recap what we did yesterday and before that. So mainly yesterday we had like in our relationship between arrays and pointers we had studied, and arrays and pointers. Arrays were static arrays. Okay, so I'm just sharing my screen to just give you a recap about it. You had seen that using, okay, you declare an array, for example, uh, size is 100, then you declare another pointer, declare a pointer p. Okay, you know why you're declaring it in this way, int asterisk p, because we want to store the address of this base address of this array b. So p equal to b, is it okay? Can we do like this?
Yes,
Yes or
sir.
no?
Yes,
Yes,
sir.
sir.
Because name of the array is the address of the first element,
Address of
or
file.
we can do it this way also. We could do it this way also, ampersand b0, address of the first element. So assigning the address of the first element of b to p, we can do it p equal to b. P is the pointer over here, okay, which can store the address of a variable. So here is the address of the first element, and we can do exactly the same thing in this way also. Now we have been doing it like assigning this p has already been declared equal to b. Yes, we can do it like this. Okay. Now, if you say that both are address, can we do like this? B equal to p? No, we can't write this. Okay. P was a pointer and it has been assigned some address. Now, you know that you learned about the arithmetic operations also. So what kind of operators you could apply on pointers? Can anyone tell me quickly?
Addition or
Sir,
subtraction.
addition and subtraction.
Increment,
Any
decrement, addition.
decrement, increment, exactly.
Increment,
So,
decrement.
right. So here you can see one example is here at the bottom of this slide. Int b, 100 is the size of this array, and again this p is the pointer which can store. Here it is storing the address of the first element. When I say p equal to p plus 1, so what it means?
Address of second
Address of
element.
next
Address
So
for
add
Address.
next
adds.
location.
Now
Second element of
here in this line p equal to b, p was a pointer variable which could store the address. So it was storing the address of the first element. Now if I say p equal to, here the assignment has been done, p plus 1, it would have just indicated the address of the second element. Okay, but in this case when I say p equal to p plus 1, so what is happening? What address is being stored in this p now?
second element of
second
the
element.
Second
Address
element.
of second
Okay,
element.
so now if the size of this integer is 4, so how much it will be added to this p?
So four.
4.
4. Okay,
4 in the address.
right. So it will be pointing towards the, or it will be holding the address, not only pointing, it will be holding, yes, pointing, of course, it will be holding the address of the first element. Okay. Any doubt about it? Any
So
questions?
sir, we don't have to write that p is equals to p plus 4 for adding 4 in its address. I was getting error.
No.
No, we will not write. 4 will mean that you jump to the which element? If I write 4 over here,
Fifth.
element.
Fifth element.
Yes. Then it will start storing the address of the fifth element.
Okay, sir.
Okay, so you have seen this subscription and dereferencing thing. You can see again this B array is there and pointer P, then you are holding the address, this storing the address of the first element. Now if I dereference this pointer and say equal to 14, so what does it mean?
Value of first element
First
is
element
14.
is
Your
First
assign
element
first
of the
element
array
as
is
element
14.
as 14, whereas I did not initialize it. I just declared this array
Declared.
P, which will be having all the elements as integer, but using this pointer dereferencing, I have assigned this 14 to the first element. Now if I say P equal to P plus 1, okay, now this pointer would be holding the address to the next location
second element.
for the
Next
second element. So if
Second
I
element.
dereference and then assign this 22, so it will be in fact the
Second element.
value of the second element. Okay. Now you have seen this is another example. You have seen that how to add numbers in an array. So this is known to you. Okay, array is there and in sum equal to 0. Okay, you have declared one variable sum, and then you can use the for loop and sum all the elements, and then you can print this sum. Okay, see out sum. So you get the sum of all the elements in this way. Now we have to use pointers. So how we can get the same result using pointers? I've shown you in my examples also yesterday also. So we have declared inside this instead of this int I, I'm declaring a pointer, and if I'm declaring a pointer, what it can store?
Address of first
Address
element.
of
So I'm writing
First
A.
element.
A is the name of the array, so address is there. So P is holding the address of the first element. Now, is it true or false? A plus 100 means what?
True.
True. True.
Yes. So it is on the first holding the address of the first element, whereas we are talking about which element? A plus 100 means what?
Beyond the
101st element.
Yeah,
Beyond
beyond
the
all
element
the elements which are
101.
there in this array. Next memory location beyond this array elements. Okay, so this is in this case first element, it is true, so it will come over here. Sum is equal to sum plus 0 plus asterisk P. Why I have taken this asterisk P? What it will give?
Dereferencing.
Yes.
Dereferencing
What
the
it will give
value
me?
stored. Value of
Value of
First
which element?
first element.
First
First
element.
element. Then it is going to P is a pointer. It is going to be P plus plus. So it will be holding the address of which element now?
Second element.
second element.
Second element.
And again check it. Condition is true. Again
Yes,
it will
sir.
be sum is equal to whatever was there in the sum last time for the first element plus the second element. So this loop goes on till this condition is true, and then you get the result. So you know how to use this pointer to get the sum, add all the numbers, all the elements in an array. Okay. Any question about this? Okay. Now this example I have shown you yesterday also how to compare the pointer address, so I'm not going to repeat it. And this const char array of pointers was also shown to you, that how you can store these strings. Okay. Now I move on to this example. You have seen this. Char, you know how to store these strings. So it's an array of pointers. I'm not writing size from here. The number of strings it is storing, it will get the size. Now what is happening in this case? Char asterisk temp. I want to swap something like Raman Srinivashan is there, then Srinivashan Raman, it should get swapped. So how I'm going to do it? See out names 2, names 3. So whatever is there at the third element or the third string, it is going to print that, and the fourth string it is going to print Raman Srinivas is there. Now I am taking this, okay, this temp. What is this temp? Temp is a pointer.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now temp is equal to names2. So what is stored in this?
Raman.
Third element.
Raman.
Address of
And
Raman.
then using this names2 is equal to names3. Srinivasan stored in names2 and names3 is equal to this temp which was storing Raman.
Raman.
So in this way, the string values are swapped, and when I print cout names2 3, so I get result like this. Okay. So
Sir,
here I'm
names2
using the
is to names2 is storing Raman or the pointer to Raman.
Raman. I get the I showed you over here also, no? I get the string like this. Okay.
Okay, sir.
I think there is that. This is the example. Okay. Some changes were done, yeah, over here. So how to get the address? It gives me the whole string, and if I want to get the address, ampersand branch in this case. Okay, so I'm getting addresses like this. Okay, then next thing which I want to show you is, so based on this, another example is there where you can see in this all the days have been stored, and then you can print them using this. You know this how I can print using this pointer. I showed you yesterday also about this kind of notation. And just now also you have seen that this using this subscript along with it and the pointer array of pointers. So you get all this days displayed over here. Now I want to reverse them. So in this sequence, it should get reversed. So how to do it? Some function has been made over here, reverse. Okay, this the parameter, which is what kind of parameter it is? Array of pointers, and the size is also mentioned over here. So what size is 6 days? 6 is passed over here, and in the for loop, you have just now seen the previous example where the swapping of these strings were done. So similarly, here the swapping has been done, and for all the days, and I'm getting this result like this. Any doubt about it? Okay, this slide will be there. You can again go through it, and then if
Sir?
you have any problem, you can ask me. Yes.
Sir, I have the doubt that we have declared the array of pointers of type char. Then how are we able to store strings?
That is how it is happening. It allows you to store the string like this. When you were having this without pointers, how you were storing it in the 2D arrays? Okay. So do you remember that this is a pointer? This is a pointer. So I can go back quickly to this slide. This slide. So what it means over here? A pointer is declared, and it is this pointing towards the first element of this string, and the last element in this string would be null character. That is how it gets terminated, any string. Now there were more strings in that array, isn't it? So suppose I want to store the root key also. This is IIT, then I want to store the root key also. So I will require another pointer, isn't it? Which will be pointing towards R.
Yes,
So
sir.
similarly, I am what I can do? I can have an array of pointers to store all these strings. So first pointer is pointing towards this, the first
Sir,
string. Then
sir,
yeah,
the size,
yes.
the size of MSG would be 1 or 3.
Where in this case?
Yes, sir.
So, it's a pointer. It's a pointer. It can hold the address of this element, first element of this string.
So can you show that slide in which ampersand was giving hexadecimals just before this? Oh.
But I'm not sure that how these 12 characters were there, and it is difference between this is I'm getting 8 only.
Okay, sir.
Okay. I think there is little doubt to you that what is the size of this thing. It's just a pointer. I can show you like this over here. So it's an array of pointers. So 4 pointers are there, isn't it? 4 pointers. The first pointer, branch 0, is pointing towards this architecture. Then branch 1 is pointing towards this electrical. It's like that. Okay with you?
Yes, sir.
Yes.
Yeah, we can. Okay. Now let me take this example. Okay, I can. Reverse one is this. Then count. So here I want to count. Suppose this in the main I'm calling a function count underscore string 1, and I'm passing a string over here, and this is another function. Some slight difference is there in the definition, so I'll show you that. So I want to count how many characters are there. Of course, you can use the dot length kind of thing also along with the string, but I want to show you the use of this pointer over here. So you can see the definition: int count string 1 char star s. So what it means? What I can pass over here? String
Address.
Pointer.
Yeah, I can pass this char asterisk s was used to
Address
store a
of
string,
string.
isn't it? So I can pass a string. I'm passing a string. Now you come inside the definition, int n is equal to 0. Okay, while asterisk s. So what it means?
Value at s.
Sir, his last value is a
Null
null
First,
value
first,
of a
first
string.
character.
Up
It
to
will
null.
be, yeah, first character is there. S is pointing towards the first character of this string. Okay, and ID references, what do I get? If
H.
I reference
H.
H. Now here come to this point, n plus 1 has been done. So means that, okay, it could read this value, it could get this value H, first character, and then that is why this n has become 1. The count has become 1. Now what about this S plus plus? Where it will be pointing?
Next character of word.
Next character of this string. So this way it can count all the characters in this string, and it will be returning some value to me. Let me see that I'm getting the result like this 5, and in the next one I'm getting 7. Okay, 5 space and then this character P. Now What about this definition? In this, again, string is getting passed, but here within this definition of this function, pointer has been declared of this type, and what address is going, PTR is going to store? Why this is S? Equal to S. Address of which element?
Address of
This array.
B.
First element.
First
element.
B, address of this B is getting. So if I say while asterisk PTR, so what it gives me over here?
So D.
B.
B. So it is true. It is true. It is non-zero. It is true. So then I say PTR plus plus. So it is going to keep on going it till the address of this P. So I'm getting the address of P and I know the address of this S also. So I can subtract it and I can get how many characters are there, right? But you are not telling me, or you're not asking me that, sir, why this while loop, how it is going to get terminated? Or anyone knows about it? You can tell me. Or in this case, how it got
So
terminated?
when it this null
Sir,
character.
because the last
Yeah.
So when it takes the null character.
Yes.
null value.
After that, all the characters of this string are over and the last character would be null. So because of that, this loop will get terminated. Okay. So you have seen this example as well as this example, how we are making use of the pointer arithmetic to get the number of characters in the string. Okay, now let us go through this example quickly. A lot of things are there in rest of the slides also. So it is a 2D array. You can declare it and assign. What about this 1, 2, 3? It goes to first row, second row, third row.
First row.
First row. So it has been initialized using this. Now I'm just using this 2 for loops to print these values. Okay. In this pattern, like rows and columns. Okay. Now what about this? If I want to print the address of all these elements, array ij, you know, it gives me that element and ampersand, so I'm getting the address of each element. Now what about this? I want to print the values of these matrix or this 3 by 3 array. Now what should I do? I'll be using nested for loops. So, but I am trying to use this PTR pointer. Okay. So before using this for loop, I am just declaring one pointer as int asterisk PTR arr is equal to arr0. So what it means, arr0 in case of integers, not in case of, this is not a case of string. So what it gives me, arr0.
First row.
First row, first element.
Yeah, first row, first element, I'm going to get it. Now you come over here in this. Now if I say asterisk PTR arr, so what it is going to print?
Value of first row, first element.
First
row, second element.
First row, second element, or first row, first element? It is evident over here.
First element.
It's printing one.
First element. Yes.
Then what will happen after that?
It will be incremented.
Incremented. So again this loop will go, and then asterisk, when it gets incremented, then to which element it will be pointing or storing the address?
Second element.
Second
First row, second element.
This loop will not be over till all the columns are exhausted. So again cout asterisk PTR arr. So it is printing this second element. So after printing this second element, dereferencing it, it will increment. Okay. Then again go back to this for loop and it will print the third element. Now all the elements are printed. J is this condition is over, j is less than 3 is over, then again it will go back to the outer loop. Okay, I. Now I will become 1, so it means that it is going to go to which place?
Second row. Internal loop.
Inner loop.
Internal loop. Yes, internal loop. Now, how it is print? Of course, and L was there, /t was there. That is why you are getting this \t was there, the spacing and going to the new line. But how it is printing the this displaying the first element of the second row? Can anyone tell me? I'm just implementing this.
The elements are in contiguous memory location.
Yes, sir. Continuous memory.
Yes.
Sir, contiguous memory.
Sir, if we see the above addresses, sir, it is continuous memory allocation.
So first row is stored, then second row, third row, like that. Row measure. By default, it is row measure. That is why if I keep on incrementing it, it's printing me for the second row. And after that, third row. Is it clear?
Yes.
Here it was 2D. Just remember this. Even in 2D, I'm just incrementing it and I'm getting the second row, third row, like that. So all the elements of the first row are stored, then all the elements of the second row and the third row. That is why I can get a result in this way. Okay.
Sir, can you once again?
Let me. Okay. I'll just compile it. Because of this, line number 6 to 11, I'm getting this result. Now, line number 13 to 18, I'm getting the addresses of these elements. Okay, so you can see that if I write cout AR0, I get the address of this first element only. Yes or no? Here I am getting the address of the first. Now, even if I say cout ampersand AR00, so I am getting this address also. This way also you can get, and in case of 2D, if you write the name of the array and just use subscript, you will also get the address of that first row, first element. These two things are okay. Sure. Now I come to this place.
Sir, can you please repeat this?
Yes, I can repeat. Now I wanted to get the address of each and every element. Though I have written in this row and column, so it's okay because and ln /t has been used. So ampersand array I0100. So I'm getting this 6ff_d0. Then for the second element, this is the address, like that, third element, and then I come to the second row, is the address. Second row, second element, second row, third. So all the addresses are written over here. Now I'm just trying to show you that if I write AR0, simply name of the array, okay, and this 0, single subscript. So even then I get the address. This address is there. In case of 2D array. Now if I want to get this way, ampersand array.
Okay, sir, I got it.
Got it? Then also I'm getting this address. Now that is why I could use this int asterisk ptr is equal to AR0. If I write this or write this, I am going to get the same thing. So address of the first element. Now I come to this for loop, which I was trying to explain you. So here in my slide, I was getting all these values 1, 2, 3, 4, 5, 6, 7, 8, 9, all the rows and columns. But in this case, I'm trying to show you that how that ptr++ is happening. You will see that. I'm just trying cout ptr. So what should I get in this case?
Address of first element.
Yes, because in line number 21, it was initialized. This pointer was declared and address of first element was stored. So I'm getting this. Some space is there. Yes. Now what I'm trying to do, semicolon is also there. Now what I'm trying to do is I can just take it downwards and then show you. Now what I'm trying to do now, cout asterisk ptr air. So what it is giving me?
Value of the first element.
First element. I got it. Now in this case, plus plus, it will be pointing towards which element?
Second element first row.
Second element. After printing it, it will increment it. And then again it will go back over here. Then what it is going to print now? PTR air. Address of the first element or address of the
second element?
Address of second element first row.
So that is why I'm getting, you can see same address I'm getting. Again it will go over here. Yeah, okay. After this it will print this value. Then again PTR plus PTR air plus plus. Okay. So this condition is true. It will come over here and it will print the address of this. So what it means? It keeps on doing it. Then the last address stored for the first row is this 6FFDD8, isn't it? Yes. After exhausting this inner loop, it will go back to the outer loop and then again come back to the inner loop. So from where it is going to start? If I say PTR air, address of which element it is going to print?
Second row first element.
Second row first element.
Keeps on happening and you get all the elements in the screen. Now I hope it is clear to you how it was happening. So I tried to modify it and show you along with the addresses. Okay, so what's there in this example?
Sir,
yes.
Sir, if we apply pre-increment operator instead of post-increment.
That you can try. A lot of things will change. Even if you take it, don't use semicolon, less than cout you do, then the address thing will not be same. See? First, first this will be incremented and then dereferenced.
Yes, sir.
Last element is stored 0.
Okay.
Yes, sir. Thank you.
So let us see this example also. Can you see the bottom of the screen? Is visible to you?
Yes, sir.
Yes, sir.
Now, of course, you know this method to use 2 for loops for a 2D array. You are getting the result like this, printing all the elements. Now I'm trying to use this pointer. So within this for loop, this has been assigned, this pointer PTR array has been assigned, or address of the first element. Then you are just comparing it, the address of the last element. Okay, and then printing all these values. Now what I'm trying to print over here, the values or the addresses?
Addresses.
It is printing addresses. So all these elements, even in the 2D array, are stored in contiguous memory location, but first row and second row and third row in that fashion. Now I'm trying to print the same, all the elements using the previous method which I showed you in the last slide. So same thing is here. I've already explained you. Okay. Now come to this null and void pointers. So if pointer is not pointing towards anything, it has been declared, and then if you say equal to 0 or equal to, write in capital NULL, the pointer is there. So if you dereference this pointer, are you going to get any value? Yes or no?
No, sir.
Zero. Zero.
Zero. Dereference the pointer which was not pointing towards anything, which was not holding address of any variable. So null pointer is a value that any pointer may take to represent that it is pointing to nowhere. Okay. Now there is one more pointer called void pointer. So they both are not same. We'll see the difference, why they are not same. Okay. Void pointer refers to the type of data it points to. And it's a special type of pointer that can point to somewhere without a specific type. So why we are using this type of pointer? It can be casted to any data type. Okay, so we'll see that. Now let me show you one example about the null pointer. Null pointer example. Okay. Now first let me take this. Okay, so in this case PTR is a null pointer. Now if I try to assign something like this, is it possible?
No, sir.
So I can do the same thing over here also. I declare it, then PTR is equal to null is also possible. CO tab X, it is going to give me. I'm not using it. Nothing is. So, I'm not getting anything. I just this thing, so it is not able to make out key. What should I do? Okay, so no, I'm not using this. So both way you are having a null pointer int asterisk PTR is equal to 0 or int asterisk PTR then PTR is equal to null. This way also you can do it. Now if I want to see that, okay, PTR was equal to 0. If it is null, then assign the address of X to it. Then what will be printed over here? 25. And if I dereference it and then assign this 100 to it, then the value of X is going to change. Okay. Yes. Now I come to same example in the slide. Now I want to show you it's not that easy to understand, but I will make you to the best possible stage I can take you. So void pointer. Now you can see int n is equal to 5, void asterisk PTR. Now I'm trying to store the address of this. Which type of variable? Integer.
Integer.
So let me look at this example where it is. Void pointer application is there. First void. Okay. Let me run it. So I cannot dereference it. What it means that it's a generic pointer, special type of pointer that can be pointed to objects of any data type. Okay, so void pointer itself doesn't know what type of object it is pointing to, so it can be it cannot be dereferenced. Okay, so here it can point to anything, but on its own it was not knowing that to which it should point, so I cannot dereference it. So for dereferencing it, what I should do? I should typecast it. So must be first explicitly typecast to another pointer type before it is dereferenced. So okay, you can see over here what is the syntax. I am declaring another pointer asterisk PET and static cast. You have to write like this. If you want to cast from void to int, and here you will write the void pointer. Okay, and then if you dereference it after using this typecasting, so this void pointer has been typecasted to this data type int. Now it is ready to point towards which type of variable? Int.
Integer type.
Now if I dereference it, and I should be getting this result. Okay, whose data it was holding. On its own, if I dereference it, it is not going to give me anything. If I typecast it, then only I'm going to get the result. So this was one thing about the okay. So can you give me some example what it is relating to you? You have water. So if you put it in a tumbler, so it will take the shape of tumbler. If you put it in a bottle, so it will take the shape of a bottle. Okay, like that. So white pointer is there, but you have to typecast it depending on the shape of the utensil. It is going to take the shape. So for giving it a shape, you are using this static cast kind of thing. Okay, it's not little complicated, but it's interesting to know about this application of void pointer. You know this enum type int float string. Do you understand this part? Yes or no? Yes.
Yes, sir.
So what is the data type as you have defined, or the user has defined type over here? And these int float they'll be representing some constants. So which constant they're representing?
Int represents 0, float represents 1, and string.
This is not in small, this is capital, so they are different from the data type. They are just some name has been given to 0, 1, 2, 3 like this. Okay, now I come to this this function, this main function where some variables have been declared and initialized. Integer variable n value, float f value is equal to this much, and then I'm trying to store this batch p. Batch p is a string. In this case, I showed you that you can store using this char pointer, isn't it? Can I use this or not? It's only one string.
Yes,
Suppose
sir.
I had to store more than one string, then I would have taken array of pointers and then within curly braces, comma, like that. But here I want to assign only one string, so I can use this char pointer. Okay, this is clear to you? Yes. Now I want to print cout autumn semester. It is 2020. Some error was coming. I can get rid of that error. That was warning, not error. So it was just a warning. Now I come to this print string will be passed to it because it's over here. And then what about this string? It will give me which value?
2.
2. Now come to this function definition. Print, of course, size z value. It is going as
String.
yes, string, and type E type. So string was
E type.
part of this E type. Okay, its data type is this type. It's going over here. Now what is getting into this switch? Which value?
So 2.
String.
String. In fact it is 2. In fact it is 2. So it will go to this case. It is not within double quotes. I showed to this thing also. You can use this enum type also in the case of switch case also. So string, it is going to go over here. So what it is going to do? Static cast char p value, this. Okay, it is going to void one is getting casted to which one?
Character.
Here it was void. As per the requirement in this case, it was char pointer. So it is getting this void type. It was passed as void type and it's getting casted into this char pointer. So once it is casted as a char pointer, then what it is going to print?
Batch P.
Batch P. Yes, it is going to print batch P. Now similarly, you can see over here, print ampersand n value. Why I am writing this n value? Ampersand n value? Because this void pointer is going to store some address. So in this case, it is going to store the address of this integer n value. Okay. Now, what about this int? It's going as I told you in the first example, that previous example, that void pointer, it can store the address of any data type. That it has done over here. It could store the address of any data type. Yes. But what about that? If I dereference it, am I going to get the value of it? Yes or no? Are you getting my point? I showed you this example.
Yes, sir.
Yes, sir.
So it could store it can point towards any data type. It's true. It could hold the address of integer also. But when I try to dereference it, so I should have got 5. Dereference this void pointer, but I'm not getting it. So how I'm getting the value of this? So before getting this value, what you have to do? You have to typecast this PTR. So to get the value of this integer, this void PTR, void pointer should have been typecasted to which data type?
Integer.
Integer. So this way I had to typecast into integer. So that is why, and then this will be stored in another integer, this thing, and I'm getting the dereference it, I'm getting the result as 5. Okay. So in this example, you can see this application of void pointer. So depending on this type, it's using the switch case, it is going to that case, and accordingly it is typecasting it to integer or float or char, and then it is giving me the result. Is it okay now? Yes or no?
Yes, sir.
Yes, sir.
Okay, you can go through it again, and then it's a simple thing. Void type can point to another data type. So that is why if I say void asterisk PTR is equal to ampersand n in first case, so yes, it is okay. But if I dereference it, that void asterisk PTR was there, asterisk PTR, so it is not giving me any value. So for that, I had to first typecast it to the integer and then dereference it. Then I can get it. Okay. Right. So the dereferencing has been done over here instead of equating it and then getting it directly. After typecasting it into integer, I could dereference it and get the result. Okay, a little tricky one, I can understand, but if you want to know more about it, then just give a little more thought to it and you will be able to catch it. So void is also there, null is also there. Now I come to this. Two more type of pointers, constant pointers. I'll just quickly show you over here. Is my screen visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Int.
Yes, sir.
So this is an array A, two elements are there. Now I'm using int asterisk before this pointer. Before this pointer, const specifier has been used. So what is happening because of this? If I dereference it and assign it, so what value will be, which element will be getting changed in this case?
First element.
First element will also become 11. Now suppose I want to increment it. I want to increment it. So this is not possible. Okay. Why it is not possible? It is going to give me this error. So because I had made it const over here, so I cannot change the value. I can dereference it and assign a new value to it, that is possible. But if I want to stores the address of that variable, now if you want to make it point to the pointer of some other variable or try to make the pointer store some other variable value or some other address, so this is not possible in this case. Okay, so if it is, I'm using this const specifier just before this declaration of this PTR thing. I can use it before int also, the int asterisk also, so we'll see the effect of it. So constant pointer, this is called constant pointer. Okay. So where I'm using this const, it will depend that whether I'm using it before this int asterisk or I'm using it after this, between this pointer and the int asterisk. So this has made it constant pointer. I cannot change the address of this stored in this PTR. Now, in this case, you see, if I block it, I'm not getting any error. So because of this, it was not allowing me to change the address stored in this PTR. Of course, using this, I can, because it was holding the address of the first, that is allowed. Yes, then I assign some other value to it after dereferencing. Okay, this is also okay. The new value has been assigned to this element, first element, but I'm trying to change this address. Now I come to pointer to constant. You can see where it is located, this const specifier, where it is located, where I put it.
Before it.
Before this int asterisk. So because of this, I will be able to store the new address in this PTR, but I will not be able to assign using this dereferencing. This new assignment is not possible because the const has been, it is pointed to a constant. Okay. What was happening in the previous case? Could I change the address stored in that PTR?
No, sir.
No, sir.
No, sir.
So that was constant pointer. And I could change the dereference it. I could change the value after dereferencing, assigning a new value. That was possible. But pointer to a constant, what I can do, I can change the address. I can change the address which PTR is holding, but I cannot
Change the value.
using after dereferencing it. Okay, So it means that it was holding the address of this variable a. So if it is const, it was a pointer to constant. So it will not be able to change the value of this variable a. Okay. But however, this pointer can point towards another address. It can hold the address of some other variable. That is also possible. So what you have learned today? Can someone quickly summarize it in the reverse order? Maybe in the reverse order. In this case, if I block it, so this is going to happen, pointer to constant. Okay, so this is there. Then I can next lecture I can move on to yes, I'm going to stop here. If you have any